Okay, we're going to talk today about direct variation, and direct variation is just kind of a fancy word for a relationship, a special kind of linear relationship. Most linear relationships that we've seen or that we will see come in the format y equals mx plus b, where, does anyone know what this is called? Put it away. Point slope form? Slope-intercept form. This is slope-intercept form. This right here is slope-intercept form. We're going to talk today about direct variation, which is essentially like slope-intercept form, except it doesn't have this plus b. So it can always be written in the format y equals kx. So that just means that y is in a relationship with x where you can multiply x by something to get y, and there's no addition or subtraction. K is called a constant. What does constant mean? Brendan? It's like in a straight line. Okay. If I say somebody is constantly on time, what does that mean? They're always on time. So constant doesn't change. And in this case, a constant is typically a number. So K is here to stand for just any non-zero constant. So any constant that is not zero. So it could be 1, could be 2, could be 1/2, could be 1/3, just not 0. So when you're looking at direct variation, it needs to be able to be written in the format y equals kx. So down here, there's 3 equations, and I want to know if they're direct variations. To figure out if it's a direct variation, where does y need to be? On the left, as long as, it could also be on the right as long as it's what? By itself. So you basically just need y to be by itself, and then you can tell if it's a direct variation. So for example, in number 1, is this a direct variation? Yes, because you've got y equals something x. So if I said, what is the non-zero constant in number 1, what would you tell me is your non-zero constant? 4. 4 is your non-zero constant. So we would say, yes, this is a direct variation, and k is equal to 4. K being the non-zero constant. Again, non-zero constant just means whatever number you're multiplying by. So in this case, we're multiplying by 4. Therefore, if I gave you something like this, and I said 1, 2, 3, 4 for my domain, my range in this case would just be all of those multiplied by 4. So for 1, what would your y be? 4. What about for 2? 8, 3, 12, and 4, 16. So your non-zero constant is just the number you're multiplying by. So multiply by 4, that's your non-zero constant. All right, what about number 2? Is number 2 direct variation? Can you tell just looking at it? Well, what do we say to be direct variation? What do you have to do with y? You got to get y by itself. So we've got to get y by itself here. So we have negative 3x plus 5y equals 0. How would I get y by itself? What would I do first? What do I need to get rid of? The 3x and the 5. Okay, what do I get rid of first? I have to get rid of the 3x first because I need to move that. How do I move a minus 3x? Plus 3x, plus 3x. What do I have on this side? What happens to it right here? That's gone. So then what do I have left? 5y equals 3x. Do I need that 0 anymore? No, that's gone. Now what do I do? Divide by 5, divide by 5. What do I have left on this side, on the left side? Y equals, how do I write this? 3/5 x, because that's just a fraction. All right, so is this direct variation? Yes, it is. What's our constant? 3/5. All right, your constant can be a fraction, just can't be 0. So we would say, yes, this is direct variation, where k is equal to 3/5. All right, so even though this looked like it wasn't going to be direct variation, once you get y by itself, you see that it is. Angel, go ahead.
What if it has intercept? Would it be direct variation?
No, like if it has a b? No. So if there's anything added to it, it's not going to be direct variation. So we'll do, let's take a look at number 3. And that might answer your question. So what do we need to do with number 3 first? Subtract 2x minus 2x. What happens on the left side? Cancels out. What do you have left? Y equals, and then what happens here? Can you put these together? No, because this one has an x and the 10 does not. So how do I write that? 10 minus 2x. So is that direct variation? No, because it's not just something times x. All right, it's got something else in it. So we would say this is not direct variation. So to be in a direct variation relationship, that means you're only multiplying by x. If you have to do anything else, then it's not direct variation. So here you have to do something besides just multiplying by x, therefore it's not direct variation. Diego. Oh, sorry, I thought you had a question. Okay. All right, what if I don't give you an equation? What would you have to do? Brendan? Yeah, figure out your rate of change, figure out an equation, right? So I need an equation. What can I do to x to get to y? So what would be an equation that I could write from this function table right here? What could I do to x to get to y? Times 6. So how would I write that as an equation? Y equals 6 times x, because I'm multiplying 1 times 6 to get 6, 3 times 6 to get 18, 5 times 6 to get 30. So then is it a direct variation? Yes. What's my k value? Yes, k equals 6. All right, what about this one? What could be an equation to get from here to here? Plus, if I do 2 plus 4, does that give me negative 2? The 4 is right. Minus 4. Good. Okay, so your equation will be y equals x minus 4. So is that direct variation? No. All right, because you're not just multiplying, you've got something else in there, so that is not direct variation. So we'd say nope. Not direct variation. Yeah.
So it can be, so it just has to be multiplication,
It can be division because, here's why, I was just going to talk about that. So it can be division because, for example, I can say y equals x divided by 3. What's another way of writing divided by 3? Times 1/3. So we could write this as y equals 1/3 x. So that is direct variation. So if it's division or multiplication, that's direct variation. It's as soon as you put on a plus or a minus, then it becomes not direct variation. So just watch out for those plus or minus. Remember that every fraction can be written as a multiplication, or every division problem can be written as a fraction. So if I said y equals 2x over 5, what fraction could I write that as? 2/5 times x. All right, what if I said y equals x over 9? What fraction would that be? What number do you put in front of x if there's nothing there? A 1. So what fraction would this be? 1 over 9x. So are these all direct variation? Yes, they all are. What's your k value for this one? 2/5. What's your k value for this one? 1/9. All right? And k, again, is just whatever number you're multiplying by. So it's not direct variation if there's what? Plus or minus, addition or subtraction. Okay? Only after you do what with y? What do you have to do with y first? You've got to get, you got to simplify and get y by itself. Okay, try these 6. All right? Okay, so when you're looking for direct variation, you're looking for a relationship between the x's and y's where you only have to multiply the x's. Why do we care? Why does it matter? If something is in a direct variation relationship, Brendan, what do you think? Because it is linear, yeah.
Not only that it's linear, but it goes straight up. It goes straight to the origin.
Exactly. Can you say that a little bit louder?
It goes straight through the origin.
Thanks, Brendan. So if it's a direct variation, that means not only is it linear, so it's increasing at a constant rate, but it is also intersecting straight through the origin. So you know that if it's in a direct variation relationship, if you have this as your coordinate plane, you know that any line that's in a direct variation relationship is going to go straight through the origin. Pretend that I drew that perfectly and it actually went through the origin. All right? So if it is a direct variation, that means it goes through the origin. We can use direct variation relationships to figure out missing pieces. So for example, let's say I tell you this. The value of y varies directly with x, and y equals 6 when x equals 12. I want to find y when x is equal to 27. So there's two different ways that we can do this, and we're going to look at the first one. I don't think you'll ever use this method again, but we're going to use it just to prove a point that we can, okay? So remember what I said at the very beginning, which is if it's in a direct variation relationship, that means y is equal to what? Kx. What's k? K is some constant, all right? So in this problem right here, we basically are trying to figure out what's that constant and how can I apply it again. So the first piece of information we have is that it's in a direct variation relationship. Okay, good. That means we can use this equation. I also know that when y is equal to 6, x is equal to 12. So what does that tell me? How can I use that to figure out k? How can I use that to figure out k? Plug it in. So y equals 6 and x equals 12. So how do I solve that then? Let me write it this way and see if that helps. Divide. All right? So I divide by what? 12, because I need to get k by itself. So now I know that k is equal to 6 over 12, which is what? 1/2. So that's equal to what decimal? 0.5. Okay, so that's k. K is 1/2 or 0.5. Now I know that, and now I can figure out what y is when x is 27 by plugging that in again to the equation y equals k times x, except this time I'm plugging in what? The constant, which is what? 0.5 times, what's my x? 27. And then that's going to give me my y. So my y is equal to half of 27. Does anyone have a calculator? What's half of 27? 13.5, good. It equals 13.5. Good. Even better. No calculator needed. Okay, this is definitely one way you can do these problems. I think that this way is fine. However, I think that you guys will be more intuitively inclined to use the next way. So the next way that you can do this is by setting up a proportion. All right? So take a look at this equation that we just looked at. All right? What is a proportion? What's a proportion?
It's basically two ratios.
Yeah, it's two ratios. So it's one fraction equal to another fraction. And when we have a proportion, what can we use to solve it?
The butterfly method.
The butterfly method. All right? So instead of using this as two separate y equals kx equations, we're going to set this up as a proportion. X over y equals x over y. Because we've been doing proportions like this since way back when we started with the percent problems, and you guys are really good at using cross multiplication, so I would use that skill here. So in our first fraction, y is equal to 6 and x is equal to 12, so I just plug that in. X is 12, y is 6, so that's 12 over 6, and then I want to know what y would be if x were 27. So where does my 27 go? Up on the top with the x's, and on the bottom I have a, I'm going to put a y because we're looking for y. All right, now what?
Cross multiply.
So if I'm cross multiplying, what do I do here?
6 times
6 times 27 and 12 times y. So I'm going to do 27 times 6. What's 6 times 7? What's 2 times 6? Plus 4. So that's 162 equals 12y. How do I finish it? Divide by 12, divide by 12. 62 divided by 12. 12 goes into 16 one time. How many times does 12 go into 42? 3 times. Man, this is annoying. Wouldn't it be helpful if I had a calculator? Yes, okay. It's 13.5. All right, so it's 13.5, which is what we got last time, right? So that's what we got last time, except I think this is more intuitive. You can do it either way. I would set up a proportion every time. All right, I think it's easier to set up a proportion. Does it have to be x over y equals x over y? Could you do y over x and y over x? Yes, you could, as long as both your y's were on top or both your y's are on the bottom. As long as your x's and y's are in the same spot, so if you've got x on top in the first one, you've got to have x on top in the second one, and vice versa. Okay? So I always just draw this little proportion for myself so I know that I'm putting stuff in the right place, because the biggest mistakes I see people make are putting stuff in the wrong place. Okay, what if I asked you to do, yeah?
It says 42 minus 36.
That's 6, right? Thanks for checking me on that. That is correct. Okay, what if I asked you this? What if I asked you to tell me x and y very directly what would you do here? X and y vary directly. Find k if x equals 40 and y equals 120. What would you do here? Do I want to use a proportion here, or do I want to use the equation here? Why do I want to use the equation here? What are you looking for? You're looking for k? Is there k in the proportion? No, so you can't use the proportion to solve for k. So what's the equation again? Y equals kx. What's my k? I don't know. What's my y? 120. What's my x? 40 times k. How do I finish that? So k equals 3. All right, so that looks like a decimal. It's not. So when do you want to use the equation? When you're looking for the constant. When you're looking for the constant, when you're looking for the k, you want to use the formula. When do you want to use the proportion?
When you're looking for y.
When you're looking for x or y. Yep. Okay, go try these. The numbers are weird on these, so this should be 1, 2, 3, and then 5, 6, 7, 8 is fine.